Hello. All right. So we're going to do 2.5. Hopefully this will help as we walk through it. We did do these examples already. At least we should have through this one. And I believe we did this one as well, or maybe we, okay, let's just start with here. So the justification for each step. The main thing that we're looking at here is that the first step, right? So we need to look at the first step, and I'm going to write over this. Hopefully we can still see it. Okay. So if I'm looking here, based on this diagram, it says the measure of angle ABC equals measure of angle ABD plus the measure of angle DBC. So it's basically saying, hey, this large angle is the sum of these two smaller angles. That right there is essentially what the angle addition, right? We're literally adding two angles together. The angle addition postulate says. We talked about one of the examples we did above was the segment addition postulate. This is the angle addition postulate. Makes sense. It's, adding angles together. All right. So the next one. Well, we're replacing ABC with 8x. We're replacing ABD with 3x plus 5. We're replacing DBC with 6x minus 16. So we're replacing them with their values from the diagram over here. So that's just substitution, and it's into an equation. And there's no actual substitution property of congruence, so we know it's going to be substitution property of equality, POE. Next thing we do is we actually is basically combining the second side together, right? The 3x and the 6x give me 9x, the 5 and the negative 16 give me negative 11. So it's combining like terms. It's fine. And then I'll put slash simplify. Hopefully we can read this over this. It's not great, but it'll do. And then we have sort of to go from, again, remember what we're doing is the step that I'm on was how I went from this step to this step is going to be this reason. So how I'm going from this step to this step will be the next reason right here. And so how did I go? Oh, well, it looks like I added, it looks like I subtracted 9x from both sides, right? And I know that because, the 9x, negative 9x will give me the negative x over here from the 8x. So it's subtraction property of equality. Okay, and then finally, how did I go from this step to this step? This is sort of a judgment call. Do you multiply by -1 or are you dividing by -1? I'd say most people would say multiply by -1. So again, how we got from the second to last step to the last step is going to give me my last reason, which is going to be the multiplication. There you go. Property of equality. So again, there's that first part that might be a little different. The rest wasn't so bad, I think. But there you have it. We're going to do the same things for this one. The difference, I think, there's not too much of a difference. Actually, I'll just do these over here. Normally we do them on the right, but just for room's sake over here. This is the same thing, right? This is going to be the angle addition postulate. Because again, what we're saying, we're looking over here, we're basically saying angle XYZ is going to be the same thing as angle 2 plus angle 3. And so what we do is we're replacing angles XYZ, 2, and 3 with their values. So again, it's substitution again. And that's property of equality. And then we're combining like terms because we're the 58 and the negative 12. We're combining. I'm not going to write simplify this time, just combine like terms. Right, and then we go from this step to this step. What did I do? Looks like I subtracted 2n from both sides, so that's subtraction. I'm doing this for room. You can write this out if you're doing 1 on your test, right? Then it looks like we're adding 6 to both sides, so it looks like addition, property of equality. Again, it's how to go from this step to this step, and then it looks like we're dividing. So to make that final step, not so bad. All right, same thing we'll do sort of over here. We'll just do it on the right side this time. Again, the same looks like the same beginning step. W, Y, V is the sum of angles 1 and 2, right? So that again, that's saying the misspelled angle. All right, we're just going to write it up here. Angle addition postulate. Bam. All right, and then it looks like we're doing the. Wait, let's see. Yeah, we're doing the same thing. I think it's 3n minus 2. So it's the same thing. We're just inserting or substituting. So substitution property of equality, followed up with in this case we're actually just distributing. So this is distributive property is a property that we've seen and used before. but it's not a property of equality because you're not doing the same thing to both sides of the equation. So we can use the distributive property, and that's perfectly fine. We just did it on only one side of the equation. Then it looks like we're combining these like terms. I'm getting more abbreviations as we go. Make it clear on the quiz or the test what you're trying to convey, and it should be okay. But if you're doing one or two of these on a test, you obviously can write the whole things out. All right, and then how do we go from here to here? Looks like we subtracted 3n from both sides, so that's subtraction, property of equality. And then finally, we're dividing both sides by 2, so that's division, property of equality. All right. Solve this equation, write a justification for each step. Okay, the first two only have one step. So like I could do that, I could write them out, but I'm just going to say that to go from here, right, we're solving it. And again, so it'll be y equals 4. And the way I went from here to here was I used subtraction, and it actually would technically be down here. Property of equality. Same thing with this one, right? We're going to add 3.2 to both sides. So we get negative 5.1 here. And again, the justification to go from here to here would be addition because I'm adding both sides. Addition, property of equality. Okay. And then in this case, it's maybe a few more steps, but that's okay. So I'm actually just going to sort of use that as my first step here. And I'll just say that that's given. Again, the same thing would happen up here. Like those would be given as their first step. So I could leave them, but it's given. All right, the next step is I'd add, I'm going to add 4p to both sides. So we get 6p minus 30 equals 6. So that would just be, what did I say? We added 4p, right? So that's addition, property of equality. Then I'm going to add 30 to both sides. So that's addition, property of equality. I could have maybe combined those because I'd be adding 2, but that's okay. So 6p equals 36. And then again, to go to the last step, we get p equals 6. We would have had divided by both sides, so property of equality there. Let's do the same thing sort of over here. In this case, that would be we'd have a given, of course, but then we'd be multiplying both sides by the negative 2. So we'd end up with x plus 3 equals, and then negative 16. So we multiplied both sides by 2. So that's a multiplication, property of equality. Then we would, of course, subtract 3 from both sides to get x equals negative 19. So that's subtraction. That's an R, property of equality. It's harder to write on this. I'm a little more sloppy on the pad than I would be sort of maybe someplace else. So be careful. All right. Not so bad. All right. So just this one last page here. It's going to stop me, and I'm going to have to make a part 2. But we'll just get started with these and pick up where we left off. This one, what I'd say, is the only one that uses something else besides beginning with the segment addition or the angle addition postulate, where this one it looks like it might be segment addition because, hey, we have 2 segments, but what are we doing? We're actually saying, oh, these are the same because they're marked as the same, so we're going to set them equal to each other. And so what that is that's basically saying a couple ways we can go from here, but the reason why I know that these are the same is because they're marked, and that means it's marked as B as being a midpoint, or B is bisecting it. So I would just say, because I'm allowed to write this because of what I know about midpoints. So I'm going to say that, this is the definition of midpoint. The definition of midpoint. You can always use definitions. So whatever definitions that we have used or have learned, we can definitely use them if that's what it's saying. If that's what it is, then of course we're allowed to use it. All right, so next thing, we're substituting again. So it's, we hopefully see kind of a theme here, property of equality. These are all equal signs, so of course that's what they're all going to be. And then we have, it looks like we're dealing with the variable, so we're subtracting 2y from both sides. So subtraction, property of equality. And again, abbreviation for brevity here, not because I don't know what they stand for. Looks like I'm going to be subtracting 6 from both sides, so that's another subtraction, property of equality. And then we have a division. Sorry, I got buzzed. Something was buzzing. Division, property of equality. Looks like I'm going to be running out of my limit here, so I'll pick up this one on the other side. And we'll do this and then the last couple, and we should be good.